So in a CNC lathe, you will be having a workpiece which is mounted in a chuck. The chuck will be present in the machine spindle. So the machine spindle is driven by electrical motors, maybe through belt drive or maybe gear drive or other suitable drive mechanisms. You can also have hydraulic drives and other things. So the basic idea here is you are having a workpiece that is usually rotating about an axis, and you are having a tool which is usually a single point cutting tool, and when it is moving against this particular workpiece, the required profiles are generated. So here the cylindrical object what you are seeing, that is the workpiece. Then it is having an axis that will be in concentric with the axis of the machine spindle. So if you want to change the axis of the workpiece and the axis of the machine spindle, then we have to use something called as a 4-jaw chuck, or maybe we have to use some fixtures using which we will be able to fix the workpiece in the machine spindle. Then as the spindle rotates, it is going to have an axis of rotation. Whatever workpiece is there, that will also rotate about that particular axis of rotation, and by the movement of the tool we are able to get the shape. So in the conventional machines, the tool is moved manually, so we have to make the accurate settings in the machine so that we are able to move in the required fashion. But if we want to do more number of jobs very accurately, making things by manual means may not be very helpful to get a good accuracy and also good speed. So usually we will be having some automation. So one such system is the CNC. So basically in a CNC you are writing a program. The program will contain the instructions to the machine about how it has to move the tool with respect to the workpiece, what should be the speed, what should be the feed, and what should be the depth of cut, and what are the points through which the tool has to move in order to get the required profile. So in this way the machine will automatically perform the required movements to get a particular shape of the workpiece. So on the conventional lathe, you are having the spindle axis, you are having the workpiece mounted in the machine spindle or the chuck. Then if you are having a human person who is operating it, he is usually standing on this side. You are having the carriage on top of which you are having the cross slide, and you are having the tool post, and you are having the tool. Now by rotating the different hand wheels, what happens? The tool can move like this. The tool can move along the workpiece, or it can move in a curved fashion. It can move parallel to the axis. So it can move in any way dependent on the movement that is given by the operator by controlling the different hand wheels, or by using certain cams and other things also it is possible to give the required movement. That is the basic tool movement in a conventional lathe. In a CNC what happens is you are having the workpiece, you are having the spindle axis. This is where the human operator is going to be present so that he can load the component into the machine spindle and he can unload. The tool is going to move on the opposite side. So with respect to the spindle axis, on this side the human being is there, the tool is present on the opposite side of the spindle axis. But in the conventional system, the tool and the human being are present on the same side of the spindle axis, because human being has to operate the different hand wheels and he has to generate the tool motion, so they are present on the both same side. In case of the CNC lathe, the tool is present on the opposite side. So even in case of the CNC lathe, you are having the tool and you can move the tool in any direction you want to generate the required kind of the profiles on the workpiece, or to generate the required shape on the workpiece. If you are having a spindle axis and you are having the movement of the tool, then what will be the nature and shape of the workpiece that will be generated? So first one, you are having a spindle axis, and this is the line along which the end point of the tool is going to move. So here the tool is moving parallel to the workpiece like this, straight. So you are having the tool on this side, so it is moving straight like that. Then what is the shape of the workpiece that is generated? So you are going to get a workpiece which is cylindrical in nature and it will be having a constant diameter. So diameter of the workpiece is equal to twice the distance between the spindle axis and the end point of the tool. So this will form the radius, and as the workpiece is rotating, that will be equal to the diameter of the workpiece. Now here we are having the spindle axis and we are having the tool movement in this particular direction. So somewhere it is very close to the spindle axis, and at the end of the movement you are having the maximum distance. So what is the shape of the workpiece that is generated in this case? It is a tapered workpiece. So here you are having a minimal radius, at the other end you are having the maximum radius. So as the tool is moving along a straight line with respect to the spindle axis like this, then you are going to get a tapered workpiece.